What's going on, guys? It's Steven here, and today we're going to be solving a LeetCode question called House Robber 3. Now, to preface, I've already solved this question before, so I'll just set a 15-minute timer and try and explain it like I was solving it for the first time. So, the thief has found himself a new place for his thievery again. Okay, let's just ignore this. We have inputs of a tree root, okay, and then we have a function called rob, okay. Given the root of a binary tree, return the maximum amount of money the thief can rob without alerting the police. Maximum amount of money the thief can rob is 3 plus 3 plus 1 equals 7, so if it robs 3, it did not rob 2, it did not rob 3, so each root.val can contribute to the sum, except there probably is some conditions for whether you cannot add a root to the sum or not, right? Because we're not taking every root. So besides the root, each house has one and only one parent house, so each root has one parent. After a tour, the smart thief realized that all houses in this place form a binary tree. It will automatically contact the police if two directly linked houses were broken into on the same night. So two nodes that are touching each other, that have an edge between them, cannot be robbed. Both of them can't. One of them can, and the other must not be. So both nodes linked together must not be robbed. You must choose maximum path. So let's start from 3. Well, if we don't choose 3, what would happen? We could choose 2 and this 3, right? So that's another possibility. Either choose root or do not choose root, and then return maximum path. And then parents want to know maximum path of picking child versus not picking child. So let's go through this tree. If there was not a root, what do we want to return? If not root, return 0, right? Because there's no sum to be had. That's a good base case, right? Def DFS root, and I think we're gonna have to DFS through this and explore multiple paths, right? Return DFS of root. Okay, so now what did I say we can do on a root? So we want to know the maximum path with root and without root. So if we do choose the root, we can do root.val plus left plus without left plus without right. Because if we do choose the root, we cannot choose the left child or the right child. If we do not choose the root, then we either can choose the left with left plus with right. If we do not choose the root, we can either choose its children So for example, if we had a 3 sorry, let me comment this out. If we have 3, then we have 2, then we have 3, then we have 3, then we have 1. So in this example, we want to let's start out with our base case, right? So let's say we get to layer 3 by just doing a bunch of left equals DFS of root dot left, right equals DFS of root dot right, correct? Let's say we're on this 3, we get 0, we get 0. What do you want to return back to this 2? Do you want to return without picking the 3? So, yep, 0 plus 0, that'll get returned, correct? And then we also want to return what would happen if we did choose this 3. So with root equals root dot val plus without left plus without right. So without both return 0, so we'll just return 3 up to 2. And then 2. What do we want to do for 2? But when we get to a parent, we want to either choose it. If we choose it, we can do this, root dot val plus So see, we don't want to return just 3 because that would force 2 to make a decision. It would force 2 to make a decision that, okay, 3 is coming. I need to either, like, we need to include an option to make these two variables separate. So see, if there is no root, we can do return 0, 0, right? And then left with left, with left. So that means we did include the left. Then without left. And this is where the 3 situation comes out, right? We want something that does include the 3 to return to the 2. And we want something that doesn't include the 3. So the 2 can make a decision based off that. So without right, and then without root, it should still turn the path below, just not the actual root itself. Okay, so return with root without root. And it should, for with root, right? Let's make sure our equation is right. Yeah, because if we choose the root. Okay, now for without root, what do we want to return? So if we don't choose the root, we might have a left and we might have a right child. Let's say we have both. As I said, we want to return well, if we choose to, for example, then no, sorry, if we don't choose to, what can we return? Well, if 3 had a directly immediate node that was below it, let's say 4, right? We would not want to include this 3 at all, and we would want to include this 4 instead. So we would want to return the maximum of with left, comma, without left, because without left would not include that 3, and it would include that 4, right? And then I think we can generalize that to the right, plus with right, comma, without right, then return DFS of root, return whichever path gives us the better one, either the path that does not include the root or the path that does give us that does include the root. Awesome. Done. See, guys, and the time and space complexity. Time complexity is O of time complexity is O of n still, because it is basically in order traversal and we have constant variable work after. I'm sorry, it's post order traversal. And then space is just, we have this 2-lane thing, but that's constant space. And then we just have the call stack. So O of n time complexity, O of n, or O of call stack space complexity, which is we can have height of the tree calls. Let me see if that's right. Time and space complexity and okay, got that right there. The recursion that depends on the height of the tree. So yeah, I said we can go as far as the height of the tree goes. So got that. Cool. So we got time and space complexity correct as well. All right. Let me see if there's anything else I want to do with you guys. Yeah, let me do one more question I haven't done, and I'll just put or not that I haven't done, I have done, sorry, and that I just need for revision. Okay, I did not look at that. We're going to go to leetcode, so we don't actually have the solution right there. As you can see, I did not solve it on leetcode. Let me just resume this timer. So given an integer array nums, an integer k, return true if it's possible to divide this array into k non-empty subsets whose sum are equal. So sum are equals means we have k sums and the sums must equal the total sum of the list. So total equals sum of nums. What I say? It said total divided by k. List equals total divided by k. Right? We want to go through this whole nums, or target. My bad. Target for each subset is total divided by k. However, if total percent k does not equal 0, then we can return false. That means that this total for this whole sum cannot be evenly divided by this k amount. So if it cannot be evenly divided, then where each group is not the same amount, then it can never become the whole sum, and it can never be equal. So we're going to return false right there if total is not divisible by this k value. If it is, then there is a chance that we can form k subsets that make a equal sum, but it is still not guaranteed. So I guess we would just have to traverse the whole list and try to put each one. So let's make an out list, not output list, but a groups list, and each group can fit a bunch of sums in it until it is less than our target, or no, sorry, until it reaches our target. If we have found a place for every number in our list, then we can return true. Awesome. However, if we don't have that, then we can go through the whole list. Actually, no, we can't. Sorry, we want to try putting this index we are on, this number at this index, into each group and explore the path where it's in that group and see if we can get to the target value. So for x in range, let me put back 2 minutes on that timer. For x in range, length of groups, if it works, well, first off, we can only add to the group if groups of x plus nums of I is less than or equal to the target. Then we can do if the fs of, okay, so we're going to simulate putting it in here, right? So groups of x plus equals nums of I, if dfs of I plus 2, so, sorry, I plus 1, we're going to the next element, right? If that allows us to put everything into groups such that they're all equal, or such that we have been able to put every index into the groups, then we can return true early, or just return true off this path. Otherwise, this number does not belong to this index in our groups array, so maybe we can try and put it in another bucket. We're basically just trying to put it in buckets until it reaches a target, right? And then if all that happens and we cannot find a group for this I, then we need to return false, because that I can clearly never fit. So, awesome. then we'll just return DFS of 0. Let me try that. Okay, valid syntax. See that right here. Return true. Awesome. Cool. Okay, so time limit exceeded. How can we get this to pass more cases? So if groups of x equals 0, there's a good optimization that you need to reason out yourself. But basically, if we go down this path and groups of x equals 0, or even if we don't go down this path, if groups of x plus nums of I is less than or equal to target and groups of x was 0 before that, then clearly it can't work for the other x values. So because if it can't work for an empty bucket, then it can't work for the other buckets, right? So clearly we can break the for loop here. That's small optimization. Also, if it has gone, oh, see, it accepts it. Awesome. So basically, and then you just got to go down each case, right? So let's say this statement doesn't hit. If it was an empty bucket and it still couldn't be less than the target, then obviously we should return false, right? However, if it did go in here and it was an empty bucket when it went in here and we could not find a path for DFS of I plus 1 with this bucket starting empty, then we know that it can't move on to another bucket and get a valid path because it basically tried every path on this empty bucket for our index value and was unable to succeed. So that will obviously return false. And another small optimization we can do is nums.sort key equals or reverse equals true, which basically just lets us greedily take the largest ones because those are the least flexible for which bucket they can be put in. So, right, you always want to put larger stuff in the trunk first before putting the smaller stuff, as the smaller stuff is way more flexible, which can be put on many more paths. So it's that principle right there. As you can see, that improved our time complexity. That is just a principle. Honestly, if you have to prove why putting bigger stuff is, other than that reasoning is, then I think your interviewer hates you. I believe that's a good enough explanation, just saying if you put larger stuff in first, it's just like how you pack for your trunk for vacation, where you put larger suitcases in first, right? And because the smaller stuff is way more flexible to weave in and around the larger stuff. So same goes with numbers and putting them into a bucket as well. Awesome. So thank you guys. Have a good day.